Welcome to Cambridge IGCSE Physics, Lesson 19.1, Melting and Boiling. Today we explore how substances change state when energy is added, focusing on the fascinating phenomenon where temperature remains constant during these phase transitions. Let's examine our learning objectives for today. By the end of this lesson, you will be able to first describe melting in terms of energy input without temperature change. This means understanding that ice becomes water when energy is added, but temperature stays at 0 degrees Celsius. Second, describe boiling in terms of energy input without temperature change. Water becomes steam at 100 degrees Celsius, requiring continuous energy input. Third, understand latent heat concept. This is the energy needed for state changes without temperature change. Now let's define our key vocabulary. Each term is essential for understanding this lesson. First, melting, which means the change from solid to liquid state when energy is added. Ice melting to water is the classic example. Second, boiling, which means the change from liquid to gas state throughout the liquid, not just at the surface. This differs from evaporation. Third, latent heat, which means the energy required to change state without changing temperature. Understanding these terms precisely is crucial for Cambridge IGCSE success. Let's explore our first core concept, the melting process. The fundamental principle states that energy breaks bonds between particles in a solid. This means particles vibrate more vigorously until attractive forces can no longer hold them in fixed positions. The definition is, melting occurs when solid particles gain enough energy to overcome attractive forces, allowing them to move freely as a liquid. Mathematically, we express this as Q equals m times L sub F, where Q represents energy measured in joules, m represents mass measured in kilograms, and L sub F represents latent heat of fusion, measured in joules per kilogram. The diagram illustrates ice at 0 degrees Celsius receiving energy input to become water, still at 0 degrees Celsius. Notice how temperature remains constant during melting. This principle is fundamental because energy goes into breaking bonds, not increasing temperature. Now we examine the boiling process. This follows specific physical principles. The fundamental principle states that energy converts liquid to gas throughout the entire liquid volume, not just at the surface. Key features include: first, boiling occurs at a specific temperature, 100 degrees Celsius for water at standard atmospheric pressure. Second, bubbles form throughout the liquid, distinguishing boiling from surface evaporation. Third, temperature remains constant during boiling, just like melting. Fourth, continuous energy input is required to maintain the process. The equation is Q equals m times L sub V, where L sub V represents latent heat of vaporization. The diagram shows water at 100 degrees Celsius with bubbles forming throughout, producing steam while temperature stays constant. Let's work through our first example. The problem states, calculate the energy needed to melt 2.0 kilograms of ice at 0 degrees Celsius. We are given mass equals 2.0 kilograms and latent heat of fusion equals 3.34 times 10 to the power 5 joules per kilogram. We need to find the total energy required for complete melting. Step 1. Write the equation. We use Q equals m times L sub F, where Q is energy, m is mass, and L sub F is latent heat of fusion. Step 2. Substitute the values. We write Q equals 2.0 kilograms times 3.34 times 10 to the power 5 joules per kilogram. Step 3. Calculate. Q equals 6.68 times 10 to the power 5 joules. Step 4. State the answer. The result is 668,000 joules, or 668 kilojoules, to three significant figures. Example 2 applies heating curve analysis. The problem is, interpret the heating curve for water being heated from ice to steam. The graph shows temperature versus time with 4 distinct regions labelled A, B, C, and D. Now we analyse each section. First, region A shows ice heating. The temperature rises from -10 to 0 degrees Celsius as energy increases particle vibration. Second, region B shows melting. Temperature remains constant at 0 degrees Celsius, while energy breaks bonds between particles. Third, region C shows water heating. Temperature rises from 0 to 100 degrees Celsius as liquid water gains thermal energy. Fourth, region D shows boiling. Temperature stays constant at 100 degrees Celsius, while energy converts liquid to gas. The flat sections prove that energy goes into changing state, not increasing temperature. Mathematical skills are crucial in physics calculations. Let's examine 3 key skills for latent heat problems. First, equation rearrangement. When we need to find a different variable, we rearrange algebraically, starting with Q equals m times L, where Q is energy in joules, m is mass in kilograms, and L is latent heat in joules per kilogram. To find mass, we divide both sides by L, giving m equals Q divided by L. To find latent heat, we divide both sides by m, giving L equals Q divided by m. Second, unit conversion. To convert kilojoules to joules, multiply by 1000. To convert grams to kilograms, divide by 1000. Third, significant figures. Your answer precision must match the least precise measurement in the problem. This maintains scientific accuracy and follows Cambridge IGCSE marking standards. Now practice what you've learned with these 3 questions. Question 1 is basic level. It asks how much energy is needed to melt 500 grams of ice, given that latent heat of fusion equals 3.34 times 10 to the power 5 joules per kilogram. Remember to convert grams to kilograms first. Question 2 is intermediate. It states, why does temperature stay constant during boiling? This requires you to apply the particle theory concepts we've learned. Question 3 is advanced. The question is, compare the energy needed to melt ice versus boil water for equal masses. This tests your analytical skills and knowledge of different latent heat values. For all questions, remember to show you're working clearly, include units in every step, and check your answers. Make physical sense. Physics principles power our modern world. Let's see how today's concepts apply in practice. In technology, refrigeration systems use latent heat for cooling. When refrigerant evaporates, it absorbs large amounts of energy, cooling the surroundings. The energy goes into changing state, not increasing temperature. In weather systems, cloud formation involves water vapor condensation. When water vapor condenses to form droplets, latent heat is released, affecting local temperature and weather patterns. In industry, metal casting requires precise understanding of melting temperatures and latent heat values to ensure proper material properties. These applications show why physics matters. Career-wise, physics knowledge leads to many professions. Engineering designs efficient systems, medicine uses physics for treatments, research advances knowledge, and the technology sector needs physics for innovation. Let's review the solutions. For question 1, the answer is found using Q equals m times L sub F. First convert 500 grams to 0.5 kilograms. Then Q equals 0.5 kilograms times 3.34 times 10 to the power 5 joules per kilogram, giving 167,000 joules. For question 2, temperature stays constant because energy breaks bonds between particles rather than increasing their kinetic energy. The energy input goes into changing the state, not raising temperature. For question 3, boiling requires more energy than melting. Latent heat of vaporization is 2.26 times 10 to the power 6 joules per kilogram, while latent heat of fusion is 3.34 times 10 to the power 5 joules per kilogram. Now, exam success tips. First, always show you're working step by step. Even if the final answer is wrong, you earn marks for correct method. Second, include units in every calculation step. Third, check if your answer is reasonable. Fourth, read questions carefully and identify command words. Let's summarize today's lesson. The key points to remember are: first, melting occurs when energy breaks bonds between particles in a solid, allowing them to move freely as a liquid. Temperature remains constant at the melting point because energy goes into breaking bonds, not increasing particle kinetic energy. Second, boiling happens when energy converts liquid to gas throughout the entire liquid volume. Temperature stays constant at the boiling point, while continuous energy input maintains the process. Third, latent heat is the energy required to change state without changing temperature. This concept explains why ice and water can both exist at 0 degrees Celsius. For further study, Review your notes regularly and rewrite definitions in your own words. Practice additional latent heat calculations to build confidence. The next lesson covers evaporation, which builds on today's work by examining surface-only state changes. Ensure you understand today's concepts before moving forward.